Hello everyone, welcome back to another video for the series. I'm Q, and today I brought a very fun and interesting problem from Balkan at Olympiad. And I really love this problem because this problem utilizes the very basic conclusions in geometry, but they're really distinct features. And uh, so I just really loved how this problem utilizes um, diverse conclusions in geometry. And yeah, so without further ado, let's start. Let triangle ABC be an acute triangle with AB equals AC. So it's an isosceles. What? So it is an isosceles triangle where this is A, B, and C. Let D be the midpoint of side AC. So this should be D. Let gamma be the circumcircle of triangle ABD. Okay. So let's draw a circle first. This looks like a circle. Is it? No, it kinda is quite flat. Don't like it. One more time. So that is a circle. Yeah, so no, why am I so bad at doing this? Yeah, almost there. Just one more touch. And perfect. Nice. So let's call this gamma. And the tangent of gamma crosses A. BC, so that point is B, BC, yeah, let's make this a little shorter. Okay, so a little more. Yeah, so that point right there is E. Let O be the circle of triangle ABE. Circumcenter. Yeah, so this not bad. Segment AO. So we need to prove that. Let's call this M. We need to prove that AM equals MC. Where this is AM equals MO. Then okay. First thing first, we know that AD equals DC. And we want to show that AM equals MO. Then I thing is quite natural to think of it like this. Let's say we'll draw a no, that's not a circle. Insert a circle. Wait, this is actually nice. Whoa, nice. Yay, perfect. So let's call this gamma prime. Gamma prime is the image of gamma. Gamma. That is the homotody. Sorry, gamma prime is the image of homotody of gamma from point A with a factor of 2. So we're going to like expand this distance twice. So like this, they're the same. This, they're the same. Something like that. We're going to do that. If point O lies on gamma prime, then we know that AM equals MO because AD to DC is 1 to 1, and gamma prime is increased increase in the factor of 2. This is 1 to 2, and therefore it should also be 1 to 2 because we know the AMO are collinear by construction. So it's 1 to 2. That means AM equals MO. So it suffices to prove that gamma prime. We don't know it yet. It looks like it, but we don't know it yet. Here we are going to use a basic property in geometry. A very famous conclusion. I think we learned this in middle school. So let's say we have this. This is tangent. So say this is alpha. This is 2 alpha. This is 90. This is 180 minus 2 alpha over 2. Alpha over 2, which is 90 minus alpha. Therefore, this angle right here is alpha. So these two are the same. That means let's call this angle why can't I draw today? Yeah, let's call this one last time. No. Sorry, let's call this angle beta. I think like the way I hold the pen matters. One last time. No, I'll just use the tool. If we call this angle alpha, then we know that this angle right here is also alpha. That's what we know. And okay, we know that. Let's take a look at this. We know the angle DCB equals angle ABC. Also, angle BDC equals angle BAC plus alpha, which is equal to angle BAE. Therefore, triangle DCB is similar to triangle ABE because these two angles and these two angles are the same. Okay, so we know that they're similar to each other. Okay, then because what other piece of information do we know? DC equals 2DC AC equals AB. Therefore, BC to BC equals BE. We just use the ratios from the similar triangle. Therefore, this angle that's so weird. I can't. I think it's time to change. Yeah. So this is a 90 degrees. 90 degree. Yes. Because these two are equal to each other, and by SSS congruence, BOC and EOC, we know that this angle is 90 degrees. Okay, then how should we continue? Let's take a look at another piece of information. Okay, what we can observe here is that should we draw a few more lines? Yeah, I think I was just yeah, I think that looks much cleaner. This one and yeah, like this. We know that we know that angle ACB ACO equals 90 minus angle ACB is equal to 90 minus angle BAE. What is 90 minus BAE now? uh 90 minus BAE. First of all, 90 minus BAE is equal to this angle. Yeah, so this angle is equal to 90 minus BAE. So this and ACO are the same, this angle or this angle. Wait, 90 minus ACB, ABE, what am I saying? ACB, ABE, or ABC, and this is equal to 90 minus, or what is 90 degrees? It is angle ABO plus angle LBE plus angle, so this angle plus this angle plus this angle, which is OAE minus angle ABE. And what is ABO plus OBE? That's angle ABE plus angle OAE minus angle ABE. So these cancels, and therefore ACO equals OAE. So OAE is OAE. Sorry, this alpha goes into here. Should we call this OAE beta? Then we know that I think this looks like a good yeah. This angle is first of all, because this is the center, this is obviously tangent, because yeah, it's tangent. We know that this is 90 minus beta. This is 90 minus beta, which means this should be 2 beta. Now, this angle right here is beta if and only if, but notice that we know that OCA is ACO, so this angle is the same as OAE. So this is in fact beta. Therefore, O lies on R prime, and the midpoint of AO lies on gamma. Wait, did I say R prime is gamma prime? Yeah. So I think the kick for this problem is noticing the homotheity and using this geometric property and using the similar triangle to chase the angles. This problem was quite meaningful because it helped me to review this property and like the homotheity. So thank you so much for watching this video. Tomorrow I'll come back with another very fun and interesting problem. Thank you and see you tomorrow. Bye.